This video tutorial will show the user how to create a line hinge in Adapt Builder 2019. And in this case, we're going to create a location where we want to have, let's say, only shear transfer along this joint here. So we have maximum bending here. We're going to basically release the slab from bending away from an actual component like a wall or a column where we can release bending about different directions. And in order to do this, we have to utilize a few of the different properties for shells. If I go ahead and turn on the shell elements for this particular slab, and we look at a shell, I'm going to go ahead and just select one of these. We can see that the shell is defined generally by certain nodes, I, J, K, and L nodes, and those reference ID numbers for the nodes. And then under releases, we can release edges of those shells both for translation and also for rotation. And we can see here we've set up releases. So in this example, we want to create a hinge line in the slab along this shell edge of shells here along this line. So we're going to release these shells from rotation about X and rotation about Y. And to do that, we have to go in and set those properties for each shell. Now, in some cases, the slab may not mesh this cleanly. In this example, I've actually meshed this slab at 5 feet, and I'm using a uniform mesh. So I have a very nice clean line along this boundary that I want to generate the hinge for. In other cases, you may be required to actually create multiple slab regions in order to simulate a straight line. So I could have also, for example, taken and created a slab edge here, and I put the edge of the slab where I want the joint, and then I would create a second slab edge here, or a second slab region rather. So we'd have 2 slab regions, 1 and 2, and that would be our joint, and then the program would mesh along that edge very cleanly, and you could go in and release the shells. So for this example, again, I've gone through, I've turned on my nodes. So from the analysis ribbon visibility panel, I'll turn on my nodes, and I'm going to go over here to visibility, view settings, and turn on my ID numbers for those nodes from the finite element tab. You can see there's a node line. Select that ID checkbox. That will show you the different elements. So if we take this element, for example, the I element and the J element is 135, 145. So we start, this is really the first node, second node, third node, and fourth node. And all of the elements should be arranged in this pattern. So this is actually edge, I'll call it E1, this is edge E2, and so on. So this is clockwise in terms of the edge arrangement. So we're going to release edge 2 for this example. So on all of these shell elements, we've gone in and we've released edge 2, you can see, for rotation. And if I just snap on a few of these, we've done that. And edge 2 there. So one word of caution: if you erase the mesh, you will have to redo this. So make sure that when you want to obtain a solution and results for this type of a run, you mesh it and you retain that mesh. There are ways to manually mesh a certain region, so I could use what's called an excluder. That excluder tool is shown here, and that excluder tool essentially allows you to generate a polygon, and the program will mesh either outside of the polygon, I'll denote that by O, or inside the polygon. So we can mesh outside of it and then manually mesh inside of it without having to remesh everything else at the same time. That's another way to handle it, but that, again, you still are required to go through and release all of the edges for the shells. So in this case, we've run the model under self-weight, we've released those edges, and if we look at, for example, the deformation in the Z direction, we can see we have significant deformation. Really, the slab is just cantilevering off of here and cantilevering off of here. You have a shear-only connection in the slab there. And if we look at moment about Y, this is one-way slab bending in the X direction. If we look at moments about Y, we can see there's our hinge line right there. That black line is 0 moment. We can also go to the analysis viewer going to go ahead and just rerun this for self-way to get an updated result. And then we'll go ahead and open up this analysis viewer here. Okay, and when I do that, if I look at the 3D translation, you can see this is kind of what that looks like right there. So looking at the contours, again, looks like that. I can manipulate the scale so we can see that a little better. So that is the result for this particular run. And then finally, if we go into generate the design cuts, I have design strips, and we design those strips. We can see the actions along those strips and design for those actions accordingly within the slab. So I'm going to turn off my contours. I'll come over here to, let me just collapse that, and I'll go to actions, bending, for example. You can see we have a hide moment here over the support. We have 0 moment where we would expect moment, and then if we look at the shear along there, this is our shear diagrams for the different strips using the support line and the design strip tools. If you have any questions about this, please let us know. Contact us at support@adaptsoft.com.